Alright, so quickly we'll go into inverse wave function just with few examples here. The common question I normally ask in inverse wave function. Like I said, there are other functions you can see, but let's see the common one. So we have, we say, given the following functions, f of x equal to 2x squared plus 2, and then 3x minus 4 over 2x plus 5, then square root of this, which will find the f of x. Okay, so the first one I've just done here, I just have to quickly do it so that I can just explain that for you. So now, to find inverse of a function is simply making x the subject formula. That's just the only thing you need to know. So if you know how to make subject formula, then you are done with this part. Of course, subject formula is something you have done in elementary mathematics in your secondary school. Of course, you can always review it and check. So once you know subject formula, forget about it. You are done with subject formula with the inverse wave function. So how do we do this? So the first you do, change that f of x to y, because f of x is y. Okay, so y is the function of x. So what you do the next, how do I make x subject formula? You move this to this side. Okay, then you now have 2s squared here. Then for it now to now remove this 2 from this s squared, first is step by step, you divide 2 by 2, so you get this. Then remember they say you should find x not s squared. So what do? You take the square root of that, you get this. So it's either you see the answer this way, okay, you see the answer this way, or you see it this way. So in this way now, they just put x here in that f of x symbol, then they change that y to x. So any of this is the correct answer. You cannot see these two options. It all depends. If you see x equal to, this is what you see. But if you see f of x inverse, this is what you see. At times too, they will put f of x inverse and they will see use y. It's also correct. Alright, so number two we have f of x equal to 3x minus 4 over 2x plus 5. That's a rational function. So in a rational function, since the x appear on both sides, okay, appear both the numerator and denominator, what we do, we want to make the x to become a single x. So what we do here is that we cross multiply 2x plus 5 against y. So if you cross multiply, this is what you are going to get. Then once you cross multiply, the next thing you open bracket, you get this. So y times this will give you this. Then collect all the x term together. So move this 2x to this side to change to minus 2x. Then move this plus 5 to come here to change to minus 5y. Then to make the x a single x, since we are looking for a single x, what do? You now factorize. So x is common here, x is common here. So bring it out. Then 2y minus 2 be left equals to this. Then to get your x, you divide through by the whole of this bracket, since you want to get rid of this. So you get this. So you can still put the answer this way or so that way. Alright, so you can pause the video for more so that I can go through my steps again and then ask any question if you have any. Okay, solving number 3 example, we have f of x. Okay, I've changed it to y equals to square root of x 5x minus 2. So for you to solve for x in that square root, you have to remove that square root by squaring both sides. So if you square both sides, you are going to get y square here, y here, the root here will go off. So you get 5x minus 2. So the next thing is that you move as we did earlier. We want to get only the x term. So you move your minus 2 to it to change to plus 2. Alright? Then you have your 5x. Now to get your x, divide to the coefficient of what? X, which is 5. So you divide 2 by 5, you get this. So we are going to get y squared plus 2 all over 5. Or f of x inverse equal to s squared plus 2 all over 5. So that is that for inverse of a function. If you have any other question, please, you can reach out on my comment section. Thank you. Alright, so next I'll be dealing on integration. I'll also rush through differentiation, the method of differentiation, then I'll also be going through integration.